Good morning.
Morning.
Okay. Um, my name is Harry Ricker, and this is the Cosmology Discussion Group for December 7th, Pearl Harbor Day, 2025. Okay, and I want to wish everybody good morning. Now, before we start, I wanted to comment that I realize that this discussion group has been going on for over a year. And nobody pointed this out to me, and I um, neglected to realize this fact. But I was going back through the recordings, and we've been recording. I have recordings going back to November of 2024, and so we've been having these meetings for over a year, and I want to thank everybody for participating um, and giving presentations and making this a successful endeavor. So I want to thank you all and happy anniversary, several months late. Okay, today we have Edo Kaal, who's going to talk to us about the structured atom model. Good morning to you, Edo.
Good morning, everyone.
Okay, do we have video for you? I don't
I'm
see.
going to find out how I can share my screen, I guess.
Yes, you need to share your screen.
Send a request.
All
All right. Okay, I guess we're ready to
Okay,
go.
good, everyone. Welcome. Thank you for being here. Today I want to do a presentation I gave a couple of years ago for the ICCF, so the International Community for Cold Fusion. So it may be a little bit dated here and there. There may be a few slides that I skip a little bit for purposes, so we have time to go into stuff later on. I'll be very open for all kinds of remarks and questions. So, what is it about? It is about the nucleus, about the elements, about the nucleus having a specific structure instead of being a unorganized blob of something. So I'm going to do that. So some findings up front. I'm not going to go through them all. It is based on a proton-electron model, meaning I'm going to state many times that I do not consider the neutron being a fundamental particle. Instead, it is constituted of a proton and an electron, and how that works and specifics about that we can go into later on. I'm going to make some comparison, and then later on in the second part, we will be having a look at what we call binding energy, mass defect and binding energy, and splitting of the nucleus in the case of uranium, for example, why that is lopsided and how all that relates to the structure of the nucleus. So many things can be stated here. It is based on geometry, not that it started out with geometry like let's take the platonic solids and make it work that way. There are plenty of people that tried that. No, the geometry was a result, if you will, not a starting point. We can do raw energy calculations of the mass of the binding energy, which no other model can, and we have many, many, many more things. So fission of uranium, we will explain the summary of the atom model in detail compared to the FCC model, which is the cubic centered model, I believe. It is based on layers, so it's still two-dimensional component. We'll be taking a quick peek at nuclear reactions, binding energy, interpretation of nuclear fission, and stress energy, that is, where is the energy hiding in the case of fission, for example? What are we talking about? What is that energy? Where does it come from? And then we'll be rounding it off. So, the current understanding of binding energy and mass defect, I'm sure everybody's seen this graph before here in this group. Average binding energy graph with a peak at around iron, nicely notated there. If you can see my cursor moving, anybody?
Yes.
Yes.
Okay, thank you. So at least I know that. So this is obviously an average. Now it's very important to note, and we can go into that later on, maybe after the presentation, but I have some more work that I'm working on right now, and that has everything to do with this topic and the mass of the neutron being erroneous, but that is a shot across the bow. So every nucleon on average has that much binding energy. So it's very important to understand what we're stating there. Binding energy, and I will get back to that, is the absence of mass, the absence of energy via E is mc squared, of course, right? E is m times c squared. But it is the average mass lacking per nucleon. So there's something going on there per nucleon. Coming back to that later. A higher binding energy, of course, larger mass defect. It's important to note that the binding energy and the mass defect in the standard model, as far as I could derive, are by definition the same, even though there are differences there. But we'll get back to that also. Next slide. So the fission enigma, for example, here, long-standing unresolved issue in nuclear physics is that none of the current models is able to explain the asymmetrical split of fission products. Norman Cook, late Norman Cook, I have to say, unfortunately, FCC model did come close with attempts, but they were still arbitrary attempts trying to find how it fits. The structured atom model, it simply falls out of it. So here we see the distribution of the fission products, right? I'm sure everybody's somewhat familiar with that as well. Then you can see that the left peak, if you will, are the fission products in the range of the 90 to the 100 nucleons, and to the right, the heavier ones, which would be the cesiums and the iodines and the whatnot. And in the center, there is nothing. So there is no even split, which is again very, very important clue. So this graph is basically contradicting most nuclear models, because there is no other nuclear model that has a specific structure allowing for such an uneven split. In fact, they usually predict an even split. So this is one of the enigmas that we're dealing with in the standard physics. So let's go into the basics and the nitty-gritty for a couple of slides there, so everybody understands a little bit better what we're talking about. Yeah, I'm going to show the page later on. That is a website page that you see here. So make a screenshot, write it down, make a photo, whatever. That's the page where you can find all the elements and see the beauty of the structure for every element and isotopes. So a quick one. We perceive this is not specific physics yet. This is more the philosophy behind it, if you will. We perceive a duality which we call a proton-electron pair with the electromagnetic force, that is a black box, acting between them. Electrostatic, I would argue at the moment. The force is the causal mechanism for the principal densest packing that creates geometry shapes based on the platonic solids. Like I said, it falls out of it. You start contracting multiple spheres to a center point, they automatically form geometrical shapes. In fact, that is what the platonic solids are based upon, the less stressful position whereby all the points, or particles in this case, have an equal distance to each other. So no more room for variation and movement, if you will. Resulting in what I would call the densest packing. So the densest packing we need to understand is the ground state. Since every nucleus, every element has a specific structure which is based on the previous one usually, it has a specific minimum densest packing. That is the ground state for that specific element. So ground state is something that is basically falls out of it as well. It is not, like I said, a lumped together collection of nucleons. So it's not, what do we have? The independent particle model, the gaseous cloud model, the plum pudding model, many more. What's important to state is, and it's all in the book that was written right after this presentation, if you will, the 2 years after it, is that there are so many observed natures and properties of the atom that completely fall in line with the structure, which is, you could make that a study object for whatever one considers it's worth or not. Fundamental physics, for the way we saw it a couple of years ago at least. We have a single, I wouldn't right now say for starters electrostatic still, but electromagnetic it could be too, I don't know. That is the single attracting force. So the strong force completely is obsolete. There is no need for a mysterious strong force. Although I have to state that the radius of the strong force is allegedly approximately, what was it, 6 femtometers or so. So you get a diameter of 12 femtometers or so, 6 femtometers or so. And that is approximately the radius or the diameter of the electron as far as we know, or the influence zone, or whatever you want to call it. So it's interesting if you reintroduce the nuclear electron into the nucleus that the range of the electron or the size of the electron is approximately equivalent to what they call the strong force. It has to be that, otherwise you get way too much binding energy, strong force in the nucleus. So they know there has to be a limitation to it. Standard physics goes into things like a quicker fall off of the strength, for example. So instead of to the second power to the fourth power, right? Those kinds of things. We consider the deuteron the basic building block of it all. The deuteron is the first true element. It is the first element that has, in standard physics, a neutron, not just a proton in hydrogen 1. So my definition is just a personal definition. Hydrogen 1 is the proton matter. That is the primordial matter, and we'll get back to that, I hope, later on. The real first element is the deuterium. Of course, it's still hydrogen, right? There's no change there. I'm not stating anything different in that way. It is the real first element because it has a neutron in standard physics, or as I state, the first nuclear electron. So this is the conceptual thing. Instead of a proton and a neutron, which basically don't interact really, except through that mysterious strong force, we will replace it by an electron being in the center of 2 protons. So now you start asking, but is this even possible? I've had that debate many times, and then people start doing the calculations if they're really persisting, and then they find out, well, actually, I have more than enough, about double the attracting force in relation to the repelling force, which makes all the sense since R is 2 times from proton center to proton center in relation to the electron to the proton center, right? Half a radius, half the force, pretty much. So that's more than enough. In fact, it can hold 3 together, which we know in the case of helium-3. So the 2.225 MeV binding energy, it's important to note that the mass defect is approximately 0.78 MeV less, so you end up with about 1.5 MeV in mass defect in relation to its constituent components, of course, being the protons mostly. The binding energy, as I stated before, is the same in the standard model as the mass defect. However, they are different values. So you can pick and choose. As a standard physicist, nuclear physicist, you can pick and choose. That's very convenient because now you don't have that error, which we come back to later. The error being a 0.782 MeV, to be specific. But regardless, the binding energy is 2.225 MeV per deuteron, if you will. And we're going to come back to that later on as well. Another point is that if you just look at the charges for a moment, just intuitively, the center be a neutralized zone, right? 1 negative charge and 2 half positive overlapping charges. So half the proton and other half the proton is neutralized, if you will, with that central electron. The outside is still half a positive left, half a positive on the right. I equate that, you do need a little bit of conversion there, but to what we call the Coulomb barrier. This is why the nuclei do repel each other. However, there's more to it. We're going to come back to that. Simplified, to get a mental image, we see here proton, neutron, electron. proton blue, neutron green, electron yellow, any pick, arbitrary. Standard model versus structured atom model. Standard model, proton, neutron with that strong force thing, and then they go into quarks and whatnot, which have never been directly observed. In between, I know nuclear physicists that were about to get their PhD, had to write 2-3 more pages for his defense in Belarus, which is high standard science, nuclear physics. And he quit because they found out the quarks was, well, not so real after all. He simply quit. In the case of the standard model, we see, of course, a hydrogen-free, two neutrons, helium-free, 1 neutron, 2 protons, helium-4, 2. In the helium-4, you always have a problem. Proton will always touch another proton or neutron. But proton is a problem because it repels each other so strongly. So you get some weird stuff going on there, which standard physics goes into a whole realm of potential solutions. Can be far simpler. Reintroduce the nuclear electron, which Bohr was so against. We're going to have to deal with that later on. The deuteron, as explained before, is a quite simple, static, very stable configuration. The hydrogen-free, the tritium, is an odd one. It's like 2 integrated deuteriums. Mind you, it is not stable because it can be more dense packed in the, if we go to the right, to the helium-free. Of course, that is the decay path. That is the decay path from the linear configuration to the triangular configuration. Mainstream has no real structure. They just throw these simple structures out usually, and that is totally biased. Of course, one less nuclear electron, or rather, one less neutron. And in helium-4, we see 2 deuterons integrated to each other. If you take an axis through the 2 deuterons, and you pull those axes to the axis of the other deuteron, you get a beautiful infinity loop, or the infinity sign, if you will. There may be something to it. I don't know. It's just an extra note. Looking at bigger structures, now this is not the nitty-gritty detail because it takes the book to explain all the step-ups, but in fact you just keep adding deuterons. Every deuteron you add, let's go back one, every deuteron you add 1 outer electron, which by definition is of course going to the next element. Therefore, in the structured atom model, every deuteron is extra is the next element, yeah? Then you reach lithium, and lithium-7 has an extra neutron, as everybody knows. Lithium-6 is the first one, of course. We made it red. Red and the yellow and the blue and the green are simply for recognizing geometrical patterns. There is no value to it other than that, yeah? Just recognizing patterns, structures. So red is a lithium, beryllium is an orangey one. Boron we made yellowish. It's now purple, I think, but forgive me. Carbon is blue. Bigger carbon is with added green, so you end up in the nitrogen, oxygen, fluorine, and neon. So there's a whole lot to explain here, but what happens is the shape we saw before, the tetrahedron, if you add one more, it starts to morph a little bit into a pentagonal bipyramid, which is a geometrical organization of 7 spheres, the only possible geometrical organization of 7, which is a very odd number, spheres. And that is lithium/lithium-6, you just take one on the side off, still stable. If you add another one, you can see it starts to morph and grow a little bit, and it slowly morphs into the icosahedron, which is the true platonic solid with 12 spheres, 6 inner nuclear electrons, or 6 neutrons. That sphere, if you let it go, and I've had an animation of it, I might find it later on. If you let go of 6 positive charges in a simple animation program, very simple, just, repel each other, but all attracted to a center point, which is platonic geometry, if you will. This is how it will organize. So it's self-organizing, which is, I believe, a very important fundamental principle for physics. Nature, the universe, on the nuclear level, self-organizing into these forms. You keep adding, you add in a problem, but it's discussed and debated in the book. There's a little gap, so 2 protons of that carbon make a little distance that is in order to fit the next step. And then you get the next step in the green there is basically the formation of the next lithium. It's like a squashed tetrahedron. Forgive me, I know I understand that you can't follow all the details, but bear with me, please. So if you look at the periodic table build-up a little bit more, you have lithium, beryllium, boron, right? Carbon, nitrogen, oxygen, fluorine, neon. Next row, sodium. Now I have a neutral ending because neon completely neutralized, chemically speaking. That is because, well, the outer electrons form a complete shielding. The positive spots I pointed out before with the deuterium on the 2 sides, the half positive ones, they are now all covered by an outer electron / inner electron, meaning there is no electron in the vicinity that can ever connect to that positive spot of the nucleus anymore because it already has one. There's no more room. Now it is a noble element. Next row, a noble side, still noble, like the neon, but one side becomes like the lithium, red. Similar, magnesium, aluminium, silicon, noble side, similar side like carbon, which chemically speaking makes all the sense because they are very similar in properties, chemically speaking. But what is chemistry and what is physics starts to become very blurry in this model because the outer electron realm is completely dictated by the nuclear structure. So they are totally, utterly, truly correlating. And that's on and on and on and on. So this is what keeps happening. For example, alkali metals, lithium, sodium, potassium. Only one red, one red, one red. The rest is neutralized like a noble gas. Carbon group, carbon, 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 or germanium and silicon. Or the noble ones, helium, which is noble, neon, argon, radon, krypton, xenon, they are all like that. So the properties of the elements are truly correlating to the structure in many, 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 many ways, all described in the book. Here we see the whole periodic table. We see many things here. You can now make a study of the elements in a very, very different way and start to understand, at least academically, why the properties are as they are of the elements. You can also understand that, for example, a titanium, a vanadium, and a chromium. Now, this is more intuitively right now than, academically founded, if you will, but there's more explanation to it. You can see a blue, a red, and a red. So many, many connection possibilities. Many connection possibilities, chemically speaking, means a very rigid structure in every direction. So it's like a steel framework. Huh. Well, these are the elements that we use for the strongest alloys that we can think of, right? Or the noble gases, total sense. Next ones. Here we see lead, the larger elements. So I just made a 2-dimensional drawing of how you could do it if you would ever envision this in an academic environment where you would teach it, just like we learn today, chemical formulas in the 2D and stuff. You could put it in a 2D or with numbers or with shapes or lines or something simplistic. It is, of course, a 3-dimensional thing. Nice in between. A year ago or so, the form of lead nucleus was determined by a very, very sophisticated group, something in the world. I forgot where it was. I think it was a research university in England, I think. And they determined that the shape of the lead nucleus was more or less like a squashed rugby ball or a circular and then, squashed Earth, right? But a little bit more. Now, and I can show it in the builder that I have, I don't have the side view of lead here, unfortunately, but you see that the side view is 70–80% of the diameter here, if you will, exactly that shape. So it was totally predicted, just a little win there. Observational data, meaning properties of the elements that were strongly used doing all this figuring out, which was a process of many, many years, and not even intentional at first, I can promise you that. Of course, neutron-proton ratio. We talked about that with the deuteron. The oxidation state, so the number of potential connections, which was a giveaway for the structure, reversely, but I didn't know that at that time, of course. Isotopes and stability, many clues there. Nuclear reactions, nuclear spin, I didn't really use that, but it's there. Is it the next gen model? So gas model, there are many models, gas model, liquid shell, alpha particle, which is an attempt to make it structured, but they always run into problems, which is explainable because you can't put two tetrahedrons together, especially not energy-wise. You run into all sorts of problems, which they try to resolve very creatively. A+ for that, but it doesn't work. I've seen so many presentations, it simply doesn't work. So I think Sam has something to offer for real in the world. We try to put it somewhere. This is for other people to do, not for me. Similarities, this was the FCC model, which was Norman Cook, who is in a way my predecessor, if you will. He talked about structure of the nucleus, how important it was, but he was still building it on the concept of proton-neutron quantum mechanics. I talked to the man after a few times. He actually went with the SAM model structurally because SAM completely safely, logically deals with the isotopes, so how many extra neutrons. There's a simple limitation to it. The neutron drip line is something that comes up. So after a certain number of extra neutrons, depending on what element you talk about, the neutrons will simply float out of it again instead of bonding to the nucleus. That corresponds to the number of connection points we recognize in the structured atom model. So, you know, Norman Cook recognized that. He didn't want to let go of quantum mechanical calculations, where there is something to say for that, because I'm not poo-pooing quantum mechanics in that sense. It is a statistical probabilistic thing, quantum mechanics on its whole, but it doesn't explain how, why, etc. So sorry, Mr. Bohr, your Copenhagen interpretation is weighed and found wanting. It's obsolete, it's not good. There are old-fashioned examples there, like a fast-moving light-speed electron within the nucleus, if you put an electron in the nucleus, which is garbage. You just went from the premises that the electron has to move with the light speed in the nucleus or something like that, which is completely, utterly nonsense. The nucleus, in this model, is completely and utterly, in principle, static. Completely and utterly nothing moves until we do something, or rather nature usually does something. You get a reaction. It is a nuclear reaction, or if it only involves the outer realm of the outer electrons, meaning simply filling up the gaps in the positive charges, that is a chemical connection, just to shield and cover the nucleus with the outer electrons of the neighboring one. I cover your back, you cover my back. We're now O2. Yeah? That's how it works. Stability, I think I've alluded to that one pretty much already. Difference between the structures, so you can see it here. He has this layers, if you will, and then he started to put certain numbers of neutrons around it, but he knew and he understood, and this is why I celebrate the man so much, because he was my single biggest competitor, if you will, but he was a gentleman. He was a true gentleman. Why? He stuck to his guns, he stuck to his model, which made a lot of sense. He wrote a whole book and compared all the nuclear models out there. It's still available. Nuclear atomic models in something. And he admitted that the structured atom model was simply superior because it could deal with the isotopes. He could not, so he was ready to accept it. Now, those scientists are rare. They are out there, and he did that. Beta minus and beta plus decay, I wish to come back to that later on, maybe in a separate session. I have so much to say there.
Can I interrupt for a moment?
Yes, sir.
Edo, this is a very interesting presentation. I would appreciate it if you'd really take your time. Don't
Okay.
try to go fast. You know, you got a lot of very interesting material here. Thank you.
Okay. Well, thank you for saying that. I don't know how it comes across, of course. That's always different. I will try to slow my pace, but my intention was to give you, I would, I see this as an introduction, and if you guys want to, I'm more than willing to spend every Sunday on this topic. I don't mean to steal your time here, but I'm just saying, yeah,
I might just mention, if I may, that in 2 weeks' time you'll be giving
yeah,
a presentation to the Saturday session. So
yeah.
I'm not sure if you'll be expanding some elements or not.
Well, not sure there. Well, I have lots of material, no problem there. But I just can I present it decently is the question, yeah? We'll get back to that in the 2 sessions after this one, yeah?
Okay, to give another chance anyway to consider
Yeah,
material.
yeah. We're going to do some repeating there for sure.
We have about 6 minutes.
Okay, we'll see how far we get. Beta minus beta plus decay, we will get back to that much more detail, but you see here in the structured atom model how that would be visualized, yeah? So the yellowish ones are key here. Those would be your neutrons, right? So a neon carries 23, carries 3 neutrons. Based on the ground structure, neon 20. You can't go below that. Then it's no longer neon. To a sodium 23. This is a normal natural decay, right? So you see how it would form the red again becoming a sodium 23. Conversely, beta plus decay, we take away one of the anchoring points, the neutrons on the left side, we knock it off in a particle accelerator, whatever. And then the nucleus goes like, okay, charge-wise, remember, there's, I don't have them depicted here, but there's these electrons in between the deuteron nuclets, the pairs, if you will. And now here's a very positive center, if you will, and there's quite a bit of negative there. And if it goes there, which you see on the right side, it has to draw in an electron to accommodate that proton there. That is your electron capture slash beta plus decay. Now, energy-wise, it's of course driven average binding energy, mass defect, or binding energy, we usually say. Of course, this is a lower state of energy, a lower ground state, if you will, right? So that's why it goes to the right. And that's where the problem occurs in the mainstream. Tritium and carbon-14 are two naturally occurring isotopes, and when they decay in the wrong way, meaning going into a higher ground state, which should not happen, but we can solve that. An example of alpha particle decay, it's just an example how we envision it. The deuteron, the extra deuteron on top of the green, you get a red. So there's a deuteron there, deuteron there, a deuteron there, if you can still follow my cursor, I hope. When two of those come together, or those endings, if you will, those red parts or those green parts, they fly off. Now, of course, there's I can't go into that in this presentation, but there's a whole calculus about the binding energy, and that is the new stuff as well. But you can see how it would basically shed an alpha particle. More and more and more. So basically what we're depicting here is the normal natural decay chain of, for example, from plutonium all the way down to, lead. For example, radon, polonium, lead, or bismuth, polonium, lead. So it's just, it can handle it. Uranium, the most beautiful one, and then I think we have to skip sessions. As you can see, this is not an evenly volume distributed sphere, meaning no even split. No matter where you cut it, if you will, you get different sizes. The bottom right is, I think, the best way to look at it right now. The center piece is the piece that's remaining, if you will. And that is the right side of the peak of the graph. So the heavier fission product. The two lighter branches, as I call them, not too dissimilar of a tree, they break off because they fuse together. You can't really see it. I can show it later on in the next session in 3D, so everybody can see it really well. Here it comes together, and when it connects, it kind of clicks together. The last little bit of distance clicks together, and therefore it snaps off at the bottom. These two lighter components, the right one here, so potassium, titanium, they fuse together. Therefore, it splits off at the base. Now the binding energy really kicks in, releases all that energy. Those two fused products are the left graph, if you will. Interesting note, fission can sometimes split in free products, which we've depicted right here, because it has to do with the reason of the fission. But, you know, nature is a bit more diverse than simplistic black and white. But we can this falls automatically out of the model. So there's no, let's make this shape now, let's make that shape now, that's convenient, right? The shape was determined for all the elements. Then came all the research. Then came all the stuff. That's what we're showing here.
Okay, we got a minute.
Okay, cluster fusion. I'm almost there, I think, but we'll continue on the next part and then we're quickly done. Cluster fusion. This is, of course, a presentation given to the cold fusion group. So we show how an oxygen and a carbon could fuse to a silicon. I'm personally, and this is a biased belief, I believe nature does this all the time, especially with oxygen. Oxygen, because it's everywhere in water. It's how gold is made. Base metals, pressurized water, highly pressurized deep down the bowels of Earth, high temperature, high gaseous, loaded with extra light metal and elements, and then it suddenly gets squeezed through those things that we call quartz veins and whatnot. And then at the edge of that wall, we find the gold, specifically there. I think this is the fusion process that occurs a whole lot. MOXIE fusion, metal oxygen fusion, or a hydrogen, which they talk about a whole lot. Hydrogen plus a metal, especially palladium. You can mutate it to silver, which they see and then they ignore. And then they say it's hydrogen plus hydrogen making heat.
Hey, we lost Edo here. What happened to him?
I don't see him here yet.
Yeah, that was kind of abrupt. I hope he's still not talking.
I can poke him on Discord if necessary. There he is.
Oh, there it is.
Okay, welcome back.
He's muted.
Yeah, you're muted, Edo.
I think I have to do the share thing again.
Yes, you do.
Send request.
Okay, that was very good. I thought the business about gold was very interesting.
I have, I think, a few more slides, and then I want to show you the builder, and then I'm done, I think, if that's okay.
Sure.
Gold always piques everybody's interest, Jerry.
Can
you see the presentation again,
once
please?
again?
Is the presentation visible again?
Yes.
Yep.
Okay, we're back. We left off at cluster fusion, so I was explaining that the cold fusion community sees a lot of stuff happening, of course, in palladium electrodes or nickel-copper palladium or some variations. And then they load it. Palladium is like a sponge. Palladium metal is like a sponge to hydrogen. It can apparently have boatloads of hydrogen in the metal lattice. I'm convinced when I read papers that at the surface, we're talking literally at the surface of a metal, just a hunk of metal, hydrogen does things there. Studies have shown there with potential results. I'll be careful. potential results of showing, hydrogen-free or helium-free or that kind of stuff just at the surface. At the surface, you have, usually the highest potential voltage. So every slight voltage, things happen apparently. And then they zap it, of course, a little bit, put a little current on it or heat it or whatnot. And the claim is, at least that's one camp within the cold fusion community, that it's a hydrogen to deuterium fusion into helium-4, which is, of course, the Pons and Fleischmann, or Fleischmann and Pons experiment in, what was it, 89, I think? Something like that. And but I believe that this here is happening a lot. This may also happen a little bit, but also, of course, the fusion of the hydrogens to the metal, doing one step up transmutation. And then I believe things like fission-like events are even happening within the LANA community, because what we see is the palladium is, when they do the chemical analysis of a palladium electrode with this hydrogen loading, and they do the chemical analysis afterwards, what is often seen is stuff like carbon, silicon, oxygen, titanium, vanadium. They're all smaller, all chunks of this stuff. So I have another presentation, one of the last ones I gave in Poland, I think it was, almost 2 years ago now, where we show, and I can show that later on, where we show you just break off the left part of that, here, the bluish one, and break off that one, and break off that one, and you have precisely have those elements they observe. And then we get tumbleweed passing by. So the Fourier cycle, the breeding process, still just showing, the model can handle all these nuclear processes so easily. Not even if they're not truthful, right? The structure, even if there are mistakes in the structure, it is simplistic and truthful, and you can easily map forces and charges and energy levels and whatnot on it. Binding energy. We're getting into the good part. I need your time still. Okay, we establish a strong relation between the properties of the elements and the structure of the nucleus. That was basically the whole introduction, and now we're going to get to the physics part more. When we compare these to the binding energy, so that was an experiment for me, because I went to the cold fusion community, I talked all about the structure, I had nothing about binding energy or mass defect, nothing. I was aware of the whole topic, but I didn't do anything with it regarding the model. And these guys kept talking about it, presentation after presentation, how they tried to. I go like, okay, if I'm so arrogant and say there's something to the structure, then there must be a true correlation, right? So I tried. And it is, and it's there. If you, hey, something happened there. Am I still on?
Yes.
Okay. A page flipped. The deuteron has that 2.225 MeV energy, as I pointed out at the beginning. That's what I call one line of connection. Deuteron, one line. A tritium, two of them, right? Here are already 3 lines, because they are 3 proton-proton connections. So, simply translated, a proton touching a proton is a line of connection. And one line of connection is 2.225. Quite simplistic, no? The only complexity arises from the structure. That's all. So, count the number of touching points times that value, and you have more or less your binding energy, right? So this is just, the Excel sheet and some the substructures that I pointed out with the colors, like the lithium and the carbon and the whatnot. You see them back. So in the large element, what was it here? I'm not sure which we took here. Iridium 191, just arbitrarily chosen. You look at it, you go like, okay, it has that many carbon nucleates, icosahedrons. It has an ending such and such, an extra neutron here and there. You just, add them up, multiply, done, that much. That's what we did, very simplistic. This is the graph you get between what we know, the literature value, the officially accepted values, and what we calculate. What we calculate is in red. The literature value is in blue. Now, when you look at this graph, at least they try to teach me in my analytical chemistry days, right? Produce this kind of stuff and interpret it and whatnot. We can see the bottom half of the graph, if you will. They are, you know, totally corresponding. There's a nice bump there. They're still corresponding. Here, just in this area, if you can still see my cursor, it starts to deviate, right? Now, if you check the number, that'd be around iron, interestingly. And then more and more and more and more. Second conclusion, the red line is linear, the blue line drops off. Which makes all sense. And there are jumps in between that has to do with, you know, many extra nucleons to the next element. So you get, you know, a little jump there and whatnot. But this is, I believe, a very important simplistic graph that you can make for that. Again, this was my experiment. This guy's talking about it. Let's try it. So we did. Here is the deviation, just to rub it in a little bit. Every step, so from one element to the next, and the difference between it in the standard model, and every element to the next, and the difference between it in the structured atom model. And then we compare those for each step. They are not exactly the same. That is because the structured atom model is not precise yet. We'll get back to that much later on as well. But it was, like I said, a quick and dirty one. Does this work? And every step you can see a big step for the standard model, a big step for the structured atom model. Small step for the structured atom model, small step for the standard model. And that is pretty consistent. And obviously in the beginning much more truthful than later on. Pointing it out in another graph, so just the deviation a little bit in the graph, again, the tipping point here, just around iron. The first, very nice correlation. Here you can see that there's something up. There's something going on still, and that is that error that I pointed out that does a lot here. I didn't know that back then. But it's not nuanced, so you work with rough numbers, so your error becomes relatively bigger and bigger. Yeah, but for the rest, again, the same result. So I pretty much summed it up already. So what I do conclude, and that was my conclusion at least, there's a real correlation going on here. There's something going on here that's more than coincidence. Because obviously this is not fudgeable. You can't make this coincidental. There's way too much statistical truth here, at least. I don't know if there are people here that know their statistics, but there you go. I used to. I don't anymore. I used to. Predictive capabilities are, well, it's just, yeah. It's just the binding energy values, of course, you know, you see the uranium where the triangle is, to the lighter fission products. Of course, it's downhill binding energy wise or ground state wise. Yeah, it's just the normal explanation. That is truthful. It's still interesting, right? Why on the left the so-called fusion works, on the right the so-called fission works. I'm here to tell you today that is the wrong interpretation. It's wrong to state that. But whole tribes do it. It's just wrong. A fusion of an oxygen after an iron is totally viable if you calculate the binding energies. What do you mean it's not viable? You mean an iron and an iron, perhaps, but an iron and an oxygen works just fine, downhill towards a lower ground state, yielding energy. So, you know, that is not a correct statement. Splitting of the atom again. Here we see some graphs, some more detail to what I already explained in the splitting up to the uranium. On the right, the bottom right, oh, the bottom right is an interesting one. You see two graphs here, two results, if you will, in the graph. Here you see one that increases in number of nucleons. right? Number of nucleons, and you're dealing with more and more the whole actinide uranium series, whatnot. So you see the thorium, uranium, plutonium, okay? And then the heavier part and the lighter fission part. Sorry, this is the lighter fission part at the bottom, of course. Less. So this is the lighter. This is the heavier, the chunk remaining in the center, as I pointed out. The center part, pretty much unaltered, which makes all the sense in the structured atom model because that's still the center part. You start overloading the uranium into heavier nuclei, it's on the outer parts where it grows. But those are the lighter chunks coming off, and they show indeed the progression of the number of nucleons. So again, supporting, indirect perhaps, but evidence for it. Some mass defect. I want to skip this one. That's just going to be confusing right now. This was some practical evidence from the Sapphire project. I don't know if anybody heard of that one before here. It was a electric universe experiment to prove the sun is electric, the electric sun model. They claim they've totally proven that. I would not be so definitive, but there were some very nice results nonetheless, and I'm talking electric universe-wise. I do want to make a shout out to the electric universe. First of all, they put me on a podium, so I'm ever grateful, biased. But the concept of the universe having an electric component is super critical to understand, I believe, cosmology and even the nucleus. Everything is charged, everything is electric, everything. Chemistry is totally it. Plant life uses charge. Our biochemical processes totally do that with proton pumps, currents through nerves, etc. And there's a translation to the chemistry components, hormones and whatnot. So the electric universe is something to bring to the table of science, and quantum mechanics completely ignores them. And that is a shame, by the way. That is an utter shame. I'm not saying believe, Venus was a comet, even though it may have been. That's not important. What's important to understand is the whole cosmos is largely ionized, electric. Currents can flow through space. Huge amounts of amperages can go through space. But it's really, really big, so, you're not going to be zapped. There's not going to be a lightning jolt just like that. But it's important. Charge, perhaps, is even a better term. Some more supporting evidence. It was very practical. Here you can see the results, that there are anomalies in the chemical analysis. And also, as I pointed out, always, all these experiments, which I've been pointing out to, rubbing the nose in it, rubbing it in their nose, under their nose, it's always lighter elements that are created. You're dealing with fission. My conclusion in the other presentation is, and I'll give it here extra, these guys with the cold fusion community have been doing these hydrogen-loaded metals. The European Union is doing a whole project on it and failing tremendously. They don't even know, and I rub their noses in it again, you're fissioning stable, heavy elements such as a palladium. You're fissioning it, or spalating if you want to prefer that term, or come up with a completely another term, be my guest, I don't care. You're disintegrating heavy, stable elements. If there is ever a promise for a revitalization and a revolution in nuclear physics, it's that one. And what did I hear? Tumbleweed, because they don't go there. It's impossible. How can that be? Well, you're doing the same thing as the mainstream is doing to you, cold fusion community. You don't believe it. But the results, experiment after experiment after experiment, and we do have experimenters coming up to us. They do. They go like, yeah, I saw a lot of carbon and a lot of oxygen. And we keep predicting carbons and oxygens are the predominant ripped off side structures. So apparently, but that's a big taboo, we can fission stable heavy elements, lead, thorium, uranium stuff, but also barium, lead, that kind of stuff. Some more experimental evidence all over the table, creation of lighter elements. So conclusions, the calculated binding energy minus the observed binding energy appears to equate what I call stress energy. So that is the energy that, is unfulfilled, because I hope I can debate that with you guys rather than me giving you answers that may not be definitive or conclusive or anything. I'd rather debate it with you. Binding energy, when we put stuff together, like a helium nuclei, it emits a lot of energy, 26 MeV or so. Therefore, the mass defect is, oh, wait a minute, that's a little bit lower error side, but still equivalent, 24 or so, MeV. That is the missing mass when you measure the mass of the helium-4 nucleus in relation to its constituent components. 4 protons, a couple of electrons, or you take the neutrons and a couple of protons and a couple of electrons. Regardless, you get that mass defect. The helium nuclei shed mass in the form of energy, light. Mass becomes light. Einstein was right there, guys. So sorry to say. But, he is not the creator, I think, of it. But the ESMC square is true. I'm exposing exactly how and why. This is not the end of the whole story here, right? There's more to say about the binding energy, how that exactly works. That's another presentation in a new book, which we're working on, and I hope to debate with you guys. But this is important. I believe we've came up with a structure for the nucleus that is consistent, coherent, and neatly, without fudging, correlating to the chemical and physical properties of the elements. You get a simplistic model. There's no need for antimatter. There's no need for a mysterious strong force that you have to plug in somewhere. There's no zipping around at light speed, relativistic electrons or whatever. It's a static, organized thing, which makes all this sense because chemistry is organized. Let's see, a rock in the, it's organized. A house is organized. My cells are organized. The structures in my organelles are organized. Everything is organized. Well, there are, chaotic systems out there. I'm not disputing that, but everything is ordered and organized, and there's a lower ground state, and there's no more energy in the system, and then it has a specific thing. And what I pointed out, nature in the nucleus, by simply letting it go, charge-wise, automatically creates these platonic solids in the rest of the whole element configuration. And then all the relation between binding energy and mass defect and whatnot. And we're going to go into that. Let's see, did I forget something? We explained fission. I believe the fission of uranium, this model is simply the strongest. Why dare I boast that? There is no other model that can do it, and it simply falls out of it. Is therefore this model proven to be true? I'm not stating that. I'm sure there's a lot of room for improvement and corrections and whatnot. And that is exactly what a model should be. A model should not be conclusive, like this is the end-all and be-all, right? And it can't answer all the questions. First of all, the field is way too big. You can't do it in a lifetime period. And there's change. There's changing of insights. There are different models. There are different ways of viewing things. There's different things you can pay attention to. I can pay attention to the structure and then start to understand the how and the why of nuclear reactions. I can go to the quantum mechanics and do some calculations about the probability of nuclear reaction and how much energy might come off, which contains a lot more fudging, by the way. Semi-empirical. Sounds really good, semi-empirical, not? But it's just fudging based on reality, observations. And then they tell us, don't look at the observations. Math is more realistic than the observations. That's my beef with the mainstream. And I guess why I talk to you guys. Did I forget something? So we can fission stable heavy elements. Transmutations are going on in these called fusion experiments, lots and lots of them, which they are starting to recognize. But with the strict limitations since last year, a year or so, I saw it coming, that it's only deuteron fusion into helium. Nothing else. Nothing to see here. No alchemy, please. I think that's it for now. I want to show one more. Implications. Understanding the nuclear structure is crucial to further the field of nuclear physics without understanding what we're actually dealing with here. Quantum mechanics will never bring us any progress in understanding this stuff. As it will provide the next level of understanding, and that's what we're working on at the moment very much, of the atom, and the atom is the basic building block of the entire universe. Within the atom, mass is converted to light, and the other way around. That's nuclear physics. That's where it happens. ESMC square, exactly there. And we have more to say. The 3D view, we have, I believe it's beautiful. I believe it's much more natural, much more simplistic. It does become complex, right? We can make still very complex graphs, and the structure is in three-dimensional in such a organic growth. It does become complex with the larger elements. But the basics, the fundamentals, you can teach, high school level, no problem. And that's what it should be, by the way. Any model that lacks the simplistic explanations, then it's not a good model yet. Sam makes physics practical, suitable for engineers to work with. So, and the topic of binding energy. And to visit the elements in full 3D, I hope this is allowed on this thing here. Am I switching screens here for you guys?
Yes.
Okay. So I want to show off the builder, of course, where all these elements were created in 3 dimensions. So we have, for example, the iron 56, where you can see it all. And I can throw through the whole periodic table. You can imagine this took a few hours there. First of all, many months, years to figure out all the structures and then put it all in the builder, which was created with an American friend, James Sorensen, who's a computer coder programmer, who was totally in on the electric universe, as a enthusiast, if you will, hobbyist, enthusiast. And he wanted to do something coding there in 3D. And we ran into each other, and it was like a match made in heaven. And I actually, in the end, after a long time, ended up going to the United States, to Colorado, to his cabin. And I was there for 3-4 months or so. And in that time, we built this program. So you can see the progression of all the elements. I can put in the nuclear electrons. I can enlarge stuff. I can color stuff. I can rip apart stuff. It just goes a little bit far to do all that now, but can do, let's see, what else can I do? Can I do a few things? What I also did, the properties here on the left side are all real properties. So they're not my imagination, the standard accepted properties from the IEEE or the most fundamental nuclear physics institutes in the world. Yeah, so they guard the standards and the basic values. I just forgot the name there. Except, of course, when it says SAM lines. That is, of course, totally the structured atom model calculation. So I have all the data put in here in every way conceivable. So it's like a research tool, if you will. At least that is how I use it very much. So I wanted to show you that. And if you guys want to read up on it.
Which browser are you using? Because I tried it with Chrome and it doesn't seem to. Which browser do you use? Does it work best with?
Oh, any browser, it should work.
All right.
Structured atom model. Structured atom, excuse me. structuredatom.org. Structuredatom.org.
So are you finished?
I think so, yeah. Please, comments, questions. If you're gonna line up the execution squad, I prefer the blindfold. Yeah.
All right. James had a question, and I don't think it got resolved. James Arathon?
Yeah, I'm going to ask a couple of questions. And then this is not an execution squad, because I think what you're doing is very interesting, is worth pursuing. But the mainstream will say you have a problem with electrons in the nucleus because of the magnetic moment, and also neutrinos.
Yeah.
When
do.
So what's your view on measuring magnetic moment, which is far less in the nucleus than the bare electron, and when a beta decay happens, a neutrino is released according to mainstream physics. So what's your view on those two things?
I think the electron within the nucleus is kind of neutralized. So that central region that I pointed out with the deuteron in the beginning, where the nuclear electron is, with the two protons on either side. So the central point is like neutralized. So it's basically non-registering. So you're left with two.
So that's my view, in the way that the neutrino is sort of an anti rotation thing that happens. I don't understand the neutrino, but it basically masks the magnetic moment.
Right.
But that's anyway. So that's
Well,
the direction which you would go. I'm not saying you have to understand that.
Well, let me respond to the neutrino there, right? So again, I'm going to talk from my truth. I'm not stating this is the other truth. Yeah, I'm speaking for my own truth. The neutrino was invented for two reasons, and one I always forget. But when you have beta plus decay, the electron disappears because it's not in the nucleus. Can't be, and that can't be happened in the early part of previous century, around the 1930s or so. Niels Bohr, etc., come up, and quantum mechanics was developed, and they couldn't handle a nuclear electron. And when the electron disappears, you have to make it go away. It's not yet, antimatter was involved. Then you have your spin stuff. A free neutron decay goes into proton, electron, and so much energy, and an electron antineutrino. Why? In order to match the formula, because the formula didn't match. Well, news for you, your formula is simply wrong. It's not how spin works, if it even works like that, because if I understood it correctly, but I'm not a mainstream physicist, the neutrino is derived from the magnetic moment in all kinds of difficult ways. So then they turn around, but the neutrino is real, therefore, argument, you can't have an electron, for example, because magnetic moments, neutrinos, antimatters, positrons, etc. No, these concepts were invented in the first place to fix the standard model, to fix their thinking, to fix that they couldn't handle an electron in the nucleus because they simply started with that thing goes by light speed within the nucleus. I don't know why or how, but they came up with it.
Anybody heard of ad hoc?
So the neutrino is a little bit of a fix to correct the spin value. Now, could there be something like a neutrino? Could be, but it's never directly observed. It is only observed via the thing that it might cause, because it doesn't really interact with matter, is nuclear reactions, nuclear decay. Then the neutrino is suddenly culprit. And then you have the problem, why do I need a neutrino? Well, it's often argumented, the neutrino carries off the remainder, the rest energy, right, in many of these decay steps. Isn't that convenient? Because there are many values there, totally depending on what nuclear reaction you're looking at. Well, that has everything to do with the fundamental error in mainstream physics, and I'll spill my beans here. It's a work in progress. I could do maybe the presentation in 2 weeks, but it's a work in progress, so it'll be a little bit messy, I guess. The mass of the neutron is simply wrong. The mass of the neutron is wrong. Why? Helium-4, mass defect, remember? It emitted energy, remember? So every nucleon, 4 protons, for the ease of it, in my truth, all weigh a little bit less, have a little bit less mass. How come? Where did it go? Well, that was the energy that was exposed in the form of gamma ray or heat or light or whatever, light. So how is that possible? That means the proton of a hydrogen 1, if you put 4 of them together, the proton changed. In my mind, now the standard model says, no, 2 of those protons changed into a neutron. Okay, so the proton changed into a neutron. And the neutron is now fundamental. But if you look at a helium-4 with 2 neutrons and 2 protons, and the protons are always the same, which I use in my calculation for the constituent component's mass, then the neutron mass change, which doesn't change in the standard model either. But the whole nucleus weighs less. And then they go into, yeah, but it's the system. That's where the energy comes from. What energy? What system? That's the construct, no? How does that work? No real answer there, except then they go into quarks, strong forces, and you're lost. Going back, in the standard model, helium with 2 neutrons has 26 MeV or so less mass. That means the 2 neutrons, each one of them carries 13 MeV less mass. That means the neutron is changed. In another element, lithium, carbon, any element, I have another value for the average binding energy. We looked at that graph in the beginning. Everybody thinks they understand that one. That's a real beauty, especially in mainstream. And then, you know, left is fusion, right is fission, blah, blah. It's nonsense. The neutrons change mass every time you have a next element. The mass of the neutron within the nucleus is therefore a variable. Or rather, in my terminology, the protons that make up the organization, depending on the organization, have more or less of those lines of connection. More lines of connection means more binding energy, means more energy emitted, means less mass for that involved proton. The proton in the nucleus is a variable. What happens when I give back the gamma ray? I give back the gamma ray to the nucleus, like a deuteron. So you get the photo disintegration of the deuterium. A whole paper written about it, many. And that gamma ray is given back to the neutron, and then the neutron departs the nucleus, and that neutron is now a free neutron. It's a reconstituted hydrogen 1, and it automatically decays because the nuclear electron can no longer be there.
This going on about anyway. The weak points in your model are equivalent to weak points in the standard model. But you give perhaps new routes to try and solve the problem. I admit that. So new routes to try and think about the problem.
Yes, it's a different way of looking at things, obviously. Yes.
So the only other question someone asked me, Norman Cook got cancelled because he denied the Heisenberg's uncertainty principle actually applied in the nucleus. You don't have to answer this, but you've basically said you're moving on with that direction because you're holding these electrons in exact positions to make your model. So you agree with Norman Cook on that?
I agree with Norman Cook on what precisely?
The abandoning the uncertainty principle in the nucleus.
Yes, sir, very much so.
Yeah,
very much so. The whole Copenhagen interpretation that you're alluding to, it's a postulation. In fact, it's right. It starts with, okay, we consider this, we consider that, and then everything has to yield. It's simply proven wrong in so many ways. It's not useful. It's not helpful. It's not even truthful.
Okay. Thank you very much.
It serves, here's the thing, and I think you guys are probably better equipped than I am. I'm trying to understand what happened in the early days of quantum mechanics, why they were so keen on it. They were so keen on it because they could do more or less, like I said, semi-empirical things. So it was, practical. You needed to calculate the yield of a nuclear bomb, that kind of stuff. I don't really care how it works. I want to use it practical. So that was given preference. And that's why it was developed. The how and why is completely obfuscated, and there are actually real errors. Mind you, if the error that I just alluded to, just to finish it, with the 0.78 MeV wrongness of the mass of the neutron, because the free neutron decays with that release of that amount of energy, therefore it's attributed to the neutron, and then they put that value in the nucleus, which is the wrong thing to do, and I'm working on all that with the mathematical blah, blah, blah. If you do all that and correct it for that value, now your tritium and your carbon-14 decay steps are no longer enigmatic. They are now simply going down into the ground state, right? Lower energy state. It's totally correct. The beta plus variants are no longer having the need for carrying off enigmatic amounts of energy via the neutrino. The positron is no longer needed to do away with the electron. So all these concepts, they just drop off. But I'm alluding again. So,
Okay.
so Norman Cook did these things. I totally agree with him. That's why we connected in the first place. Then we compared the models, and then the rest is history.
Okay, Edo. James, do you have any more questions or comments?
No, thank you very much.
Okay, so does anybody else want to? I bet you James Keene's got some comments and questions.
Well, he unmuted himself, so
I'm here.
Great talk, Edo. Thank you. Am I correct in understanding that a 3-nucleon object is your basic building block?
Conceptually, there are only protons and electrons, whatever they may be, both of them. The protons are connected via the electron, then it becomes a nuclear electron, that becomes the nucleus. That system, if you will, is the smallest building block for the elements. But the smallest building block is obviously one proton, which would be an electron, which would be the equivalent to the hydrogen 1. And the deuteron, so the two protons with the one electron in between, would be my brick in a wall, like the smallest building block. Does that answer your question?
Yes, thank you. Thank you.
Please continue with the question.
I might add that
the last I heard was, I might add, from James Keene.
Oh, yes. Well, I think your work is really brilliant and very, very interesting. I might add that my own work, I'd like to maybe contact you by email, but I'm also working on developing a few items in my software so that I can actually visually see the structure of various atoms. Excuse me. Yes, atoms. In other words, nuclei with Z going up 1, 2, 3, 4, and so forth. But this is in a 3-dimensional space in a cubic lattice. I notice you don't use that particular idea, but it might be interesting to compare the results that I'll be generating with what you are getting.
Right. One thing I did not mention, and that might have to do, what you might get, what you're saying is the anomaly smaller atoms, if you will, the excited, weird states that they're seeing here and there with the hydrogen 4, the hydrogen 5, or the lithium 4, you know, the real odd isotopic configurations. So they might come out of that potentially, I think. That's my first knee-jerk reaction to that. But yeah, no, I don't use a prefixed form. Like I said, if you let them go and there's a now this is modeling, right? Not reflecting truth. The truth is, of course, it's the electron pulling the protons together. It's a spiel between a number of negative and positive charges. They do attract and organize themselves. And this is, for me personally speaking, I guess the most beautiful finding. Nature is completely self-organizing and creates through that process the platonic solids and structures. So when we come along, most people, and I'm not looking at you here, sir, but most people start with 2D thinking, graphs, etc., or layers, or cubes, but they are a mental construct. I understand that it is the most optimal packing for a volume, right? That's why we love it, the cube, if you will, right? Perfect stacking. But if there's perfect stacking, there's no room for movement or whatever variation. Nature is far more clever than that, for starters. So you need the spaces. You need the natural formation. Otherwise, everything is dead. Everything stops. And the universe is a very, very lively place, I would argue, whether it's life or abiotic. But there's always, that exchange between energy. And if you do it right, there's exchange of energy and mass. And that always happens in the nucleus.
Okay, I've got some questions, and does anybody else have any questions before I ask them?
I would like to just tell James, I put up a link in the chat down at the bottom of the window. There's a chat button. There's a Discord link to anybody that wants to join the Discord of the Science Dissidents that I set up. Edo is a member there, and you can talk directly to him over a voice chat channel that's in there. So
yeah, thank you so much, because I do love Discord, because it's so easy to connect, right, and talk with multiple or one person, doesn't matter.
you can make a single call to the person one-on-one, or you can jump in a voice chat room, and you can have a group of people chatting. So come join.
Yeah.
Okay. Anybody, Vladimir
I
has
just had a
wants-
very basic question, Harry. Bit of a devil's advocate, or maybe an advocate for the mainstream.
Oh, please do.
Okay, I'll put it up to you, Edo. So it seemed to me, I mean, it's very impressive, impressive model, and you seem to be getting very good results, and that's obviously very important. But it seems to me that there's a bit of a reversion to a sort of a plum pudding type model. You might have mentioned that yourself, even. So it might be asked, how would you deal with the criticism using the Rutherford scattering experiments, where it seemed to indicate a concentration of positive charge in the nucleus?
I see no
Yours would seem to contradict. You might have a neutral sort of charge.
Okay, let's see if I can give a satisfying answer here. First of all, I do recognize something of what we call a Coulomb barrier, right? So the inside of the nucleus, if you will, if you see it as a two-layer, right, an orange and then another layer around it, kind of like the Earth is allegedly built up, yeah, two layers. The center layer is the neutralized zone, where the charges, positive and negative, are exactly equal or equally neutralizing. So it's a zero zone. The outer edges, if you will, the outer shell, if you will, that's the positive part. So that's one. That's how I see that. And what was your question again? Please repeat.
Okay, well, I'm just saying how you account for the Rutherford scattering experiments, and I think you've basically said, well, it's because it's on the periphery, the positive charge.
So these experiments that we are often alluding to, I like your devil's advocate approach here. So these experiments were interpreted from a certain thinking, right? A very quantum mechanical model thinking, yeah, or relativistic thinking. You guys talk about this a whole lot more than I do. But that was the thing, that is how people see it. So these experiments were interpreted. And when you go back now and you use this model of thinking, these experiments are not so much contradicting, but they would require redoing and reinterpreting perhaps. But it doesn't mean that they're always contradicting. At least that is my personal finding / feeling. So these things that we throw, yes, but it was concluded that blah, 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 blah. And you go back to these papers and experiments, it's not that straightforward. That's what I would argue here.
Okay, thank you very much. Yeah,
okay.
Vladimir.
Yes, sir. Edo, thank you so much for great presentations. Everything was so new for me. It was very much curiosity of me, satisfied. But my main curiosity, my main concern is annihilation, self-annihilation, and gamma radiation. Do you have a mechanism of this process?
The gamma radiation comes from nuclear reactions. That's one.
Yes.
And this is a work in progress. I can't show you it in a neat presentation. We're writing a new paper/book on it, but I have extensive notes. The gamma ray comes, as I pointed out, from usually a fusion process / a beta step, a beta decay step. Yeah, that is where the gamma rays come from. That means also the specific organization with the specific distances, even in the more complex nuclei, have these specific values of these gamma rays. That means every gamma ray would be an exact signature or fingerprint or an exact nuclear reaction. We can map completely and utterly this precisely in the end. That is the promise here. So that is what's happening. Self-annihilation, I'm not sure I understand it, but I think you're talking perhaps about a proton electron or something like that. I don't know. Or what is the
No,
self-annihilation?
not proton electron, no. Okay, let me ask you the question. What does it mean for you? Gamma radiation, gamma ray, what is it? It's electromagnetic wave? Wrong. What is it in your mechanism, in your view? What does it mean, gamma radiation?
Okay, in my view, sir, I think this is what you're alluding to, perhaps. Now, this is my personal view, okay? Mass is energy that is fixed. If energy is unrestricted in movement, it becomes light, and then there is no mass. So mass, pure mass, is one side of the balance. Pure light, or gamma rays, is the other side of the balance, if you will. Speed and all this relativistic stuff comes from this principle. So what is a gamma ray? A gamma ray is the same stuff that a proton is made of, only it moves unrestricted, so massless. Therefore, the movement is light speed. That's how I see it, most fundamentally. And the conversion process happens in the nucleus.
So
I don't understand.
But Vladimir, you said it wasn't electromagnetic radiation. What do you say gamma rays are?
I don't know. It's exactly not my point. If you have your nuclear reaction and you're responsible for it, please explain me. What does it mean, gamma radiation? Of course not. And what is important, please stop talking about pure light. There are only electromagnetic waves, and that's it. Light, it's our definition, what we can see. That's it, simple like this. That's why for me, gamma radiation, electromagnetic waves with very short wavelengths, it's bullshit. That's why I want to find out
I see it. Well,
what does it mean from nuclear point of view? What does it mean, gamma radiation?
Well, I don't think I disagree with you, sir. The whole electromagnetic explanation and all the stuff that's written about it is very flimsy at the very least. I don't know what a gamma ray is. I don't know what a proton is. I don't know what an electron is. But, and this is my argument always, I can study the interaction between them. That should be true quantum mechanics, study of the interactions of nucleons, of particles, of whatever we call it, whatever definition we give it, whatever organization we give it. Light comes from the proton. This is the most important conclusion I have. The proton loses mass in the form of light, and therefore the proton lost mass. Mass is light without moving, if you will. It's arrested movement. And light, or a gamma ray, is movement without restriction. That is the closest, most simplest, purest description I can come up with. What is it truly? Sir, please tell me, because I don't know, right? But this is the description that I use in my mind to look at this. But mind you, they are basically black boxes for me as well. And I simply admit that we don't truly understand it. But we can understand that the proton is to energy, mass is converts to energy within the nucleus. It comes from the proton. That is a big clue or a finding. Is it true? I think it's true. You guys be the judge. But look at physics, look at mass defect, look at binding energy, look at the curvature, look at the Wikipedia pages and the papers and whatnot, and you have to conclude this is the case. At least that's my new work here. Does it
Okay,
answer your question, Vladimir? Sorry.
Okay.
Do
Thank
we
you
have
so
any,
much.
do we have any other things before I ask mine? Okay. The first thing that confused me was you mentioned this Norman Cook and his FCC model. Could you
Yep.
explain what, I don't know who Norman Cook is. I think you
Okay.
may have assumed that we knew who he was and what this
No, that was because I took an older presentation for the cold fusion community, and they very much knew who Norman Cook was. Norman Cook was, like I said, more or less my predecessor, who was involved in the cold fusion field for many, many years already. And he is the one that was developing his own new nuclear model, which was the FCC model, which I compared there for a moment. He did that because when he studied the nuclear models that are out there, and there's 30 plus or so, he all found them wanting, meaning they were not good. They were contradicting each other. They were contradicting themselves. They had no proper explanation power, like the splitting of the nucleus of uranium. All of them pretty much predicted an even split, or at least, a normal distribution and graph with a normal distribution with the center peak, the even split. But in fact, we saw that the observation results show no even split. So that led him to start developing his own atomic model, and he came really far. We had many overlapping ideas and observations and convictions that it had to be a structure, that it had to be different. So the question remained for each and individual of us, what was the structure? What is the structure? That's what we were looking for. And that's where he was the gentleman when he found out that the more three-dimensional organic structure dealt with the extra neutrons, meaning the isotopes, so easily. That's when he conceded. That's why I call him a gentleman.
Okay,
That's why I brought him up. Maybe not
okay,
relevant
that
for
was
here.
very good. I'm unfamiliar with that. Um, you mentioned in several places the chemistry versus physics,
Mhm.
and I sort of would wonder if you'd sort of explain what you meant by the different. I think I understood what you meant, but I'm not really sure.
You mean the difference or the overlap, or the between?
Well, you
Well,
were talking about, it seems that chemistry has a certain paradigm, if you will, and I guess physics has a different paradigm.
right.
And it's not
So,
really clear to me when you were talking which paradigm you were referring to.
how much time do we have left? How many questions do you have?
Oh, maybe
Let me
that's
try
too much
try
to ask. I
let me
wanted
no
to
no no
talk about,
let me try and answer. So repeat your question one more time shortly, please.
I was I was just wondering when you said chemistry, you seem to be referring to like a chemistry paradigm in some places in physics.
Check.
So when you gave your presentation, you said, well,
Okay.
this is all chemistry, and now we're going to talk about
Okay.
nuclear physics. And it kind of struck me as I thought we were talking about the same thing. What's the difference
So
really?
so long ago, there was no physics, there was no biology, there was no nothing. Yeah, there was just science or whatever you want. They used the term they used. You know. Then it became alchemy. That was the study. That it was just everything basically, meaning more towards chemistry and physics leaning already. Alchemy. And then it became chemistry, and chemistry ruled the world. Chemistry changed the world. In fact, to this day, without chemistry, I think 3/4 of the people will die within the year. Probably, likely. Chemistry rules the world. Then came the nuclear era. Suddenly, nuclear physics, theoretical nuclear physics, apparently, was able to create a really, really big bomb and loads of energies in power plants. That changed everything. Now, nuclear physics, or cosmology/cosmology, was suddenly the queen of sciences, and the chemists, they got second place. The chemists were banned to the realm of the outer electrons, chemical properties, chemical properties, that's meaning, chemical reactions and whatnot. And they do not touch the nucleus anymore. That is the realm of the nuclear physicists. And these nuclear physicists right now own that realm, if you will. They own the realm of nuclear physics, and chemists are not to touch it. So chemists do learn quite a bit of nuclear physics, but relatively simplistic, so did I. So you do learn about all kinds of properties. You do learn, I don't know, orbitals. There's a strong overlap, of course, in the field of the electromagnetic field, meaning light, wavelength, etc., the outer electrons. What I'm alluding to is the nuclear structure obviously, logically, clear-cut correlates to the outer electron realm. That's why I pointed out, for example, why is an element noble, like a noble gas? Well, it is noble because the shield of the outer electron is complete, if you will, meaning those positive spots, those outer positive spots, is where the outer electron connects to. But it can't go into the nucleus because the nuclear electron is quite large, and it keeps it at bay. But it's still electrostatically attracted. That is precisely what an outer electron is. If I become too large in my spherical construction like a carbon, I am charge-wise neutral. 12 protons, 12 electrons, 6 in the inside, 6 on the outside. But because of the extra surface area, if you will, I've created about 8 extra positive spots. Those positive spots are the chemical receptivity, meaning the chemical connectivity, meaning the oxidation state, the valence factor. That is how it works. That's why carbon has a factor of 4, oxygen of 2. One side of oxygen is neutralized, one side is still chemically active with these positive spots. That's how chemistry works. So, nuclear physics and chemistry completely flow over in one another. Yes, there's of course a distinction very much here. Chemistry does not involve changes in the nucleus, that is true. But the outer electron realm, that is dictated by the nucleus physics, if you will. That's where the connection lies. I hope this answers your thinking.
Okay. Now I did want to finish up because we're a cosmology discussion group.
Sure.
And we're talking about cosmology. Do you have any thoughts about they have this idea of stellar evolution, and the whole idea of stellar evolution is you have fusion, reaction driving stars, and that continues on until you get to the Iron Peak.
Oh God, I have views. I
Yes.
do have views, sir, very much so. But I don't know. That's oh God. It's such an interesting topic that you touch upon right now. The nucleosynthesis in the stars, right? How does that work? The standard models tells us that proton-proton reactions, for example, are possible, or you get 2 deuterons combining to a helium-4, or the triple alpha process, 3 heliums into a carbon, etc., etc. I see the progression of the elements taking into account my presentation and all that thinking. First of all, we do not truly understand the function of stars at all. There's so much there that's a huge topic. I do see stars as a fusion plant, kind of like mainstream for sure. What I mean by that is I think stars, like our sun, creates the lighter elements such as carbon and oxygens. I think it's an electrostatic process whereby a deuteron can quite easily fuse together. Now that may be still a problem and it creates a tritium and a neutron, but it's a process, for example. How carbon is created, I don't know. That's the big enigma. Why do I say carbon and oxygen? Because it's in about 1% of the solar wind. It's being spit out. Then the star evolves into a white dwarf, and a white dwarf has about the chemical spectrum that an Earth has, about the same chemical makeup. So I believe a white dwarf is simply an Earth-like object. That's what my belief. And I can be very wrong there, but it's how I see it. Then those Earth-like objects with water and oxygen in Moxie fusion can do very much oxygen fusions to metals, like to an iron, and another one, and another one, and another one. And if you keep doing that, you go, for example, from copper, you reach silver. And from silver, if you do it 2 times, you reach gold. Or in iron, you go to the platinum. So these correlations that we find in geology, the correlations we find in the overlap of the properties of the elements, the progression of the elements we see in star-like objects and groupings, I think there's a tale to be told there. I think the universe is a beautiful creation and destructor of the elements through different processes. Fission is taking place a lot more also than we think, than we anticipate. That is what the cold fusion community is showing us with these experiments. So I believe this is the most beautiful topic that you touched there as a research topic. This is just an idea that I expressed in scientific terms. I believe we are just starting to do that research. I believe the structured atom model will help unlock true cosmology to see what utterly amazing universe we live in. That is how I want to conclude. You're muted. Someone is mute. I don't hear anything.
Harry, you're muted.
Yes, I know. I'd be interested. The current idea is, of course, that you have this Big Bang, a bunch of nuclear reactions at the beginning, and then gases condense down, and that sort of thing. Do you have some thoughts about how the structured atom model might relate to that thinking? Do you have some thoughts on that?
I think the universe is self-organizing from the primordial substance, hydrogen 1.
Okay.
I don't know if there's a beginning. I don't know, because where did all the protons come from? Question for you, sir. In response to your question, I will ask a question. Were all the protons available at the starting point of the Big Bang, whatever that may mean? Where do all the protons come from? Why are they all the same in mass? Why are they all the same? And why are they more or less evenly distributed? I know that's debatable, but where do they come from? Why were there so many to start with a Big Bang? The Big Bang concept, what I'm trying to say, is complete nonsense in my mind. An ever-perpetual universe, even though I couldn't explain that one either, at least makes more sense.
Okay, so what about planet formation? Do you like the idea that the elements are created in the heavier elements beyond iron are supposed to be created in supernova?
Nope.
And then they sort of come together and form the Earth. So that
Right.
would my understanding of what you're saying is that you really think that there's creation of the elements that goes on beyond that.
Yes, I
That's
think the heavier elements are created on planetary objects. And this is not a joke. This is my true feeling. The other process you're referring to is like the rapid neutron or the rapid proton capture processes, etc., with exploding or colliding neutron stars, etc. And I'm just going here for it real quickly. It's impossible. It is completely and utterly impossible. A neutron star is a nonsense concept. First, it breaks in so many ways.
well, I was going to ask you about that.
And then to add that the rapid capture process of all those neutrons coming from a neutron star, caught by an iron that is floating happily out there, catching all those neutrons, it doesn't happen. That's why I put the neutron drip line in the book. After 10 or so, whatever, I don't know the value with iron, but carbon has a neutron drip line value of 20, meaning 8 extra neutrons, then it's done. It's burped, it's full. Don't fit no more. Thank you very much. No vacancy. So how is a carbon going to mutate to a gold or an iron? Then take the decay steps into account. They take time. Before that time is passed, all the other neutrons are long gone. So creating a lot of uranium and then going out on a limb, all that uranium comes together in an Earth-like object, contraction and all that stuff that you're alluding to, not you, but the mainstream is alluding to. And then we find most of the uranium and the gold and way on the outside of the planet. Because if we drill really deep holes, we find silicon, carbon, water, and a little bit of hydrogen and helium. That's about it, meaning the lightest elements. The heavier ones are at the edge of the Earth, through veins and whatnot, and those veins were created perhaps with electricity, cataclysmic-like events, or perhaps when we were still a star-like object. Now, this is speculation that I'm doing now, so, right, that's speculation. But it's speculation that is based on my findings, and I think that's what you wanted to hear here, so there you go.
Sounds like
Yes, I
you're
see it
talking
very,
about,
very differently than neutron stars, etc. I see a progression from stars to planets, and as you go along in that progression, you also find heavier and heavier elements. But nature built in a safety valve. Too big is not good, otherwise, the universe would become one big atom. Can't happen. So they split apart when they become too heavy.
okay, um, forgot what I was going to ask.
Then
Um,
question.
uh, this idea that the elements are birthed in the earth is an old one, which, are you familiar with that idea that the elements, gold and the metallic elements are formed in the bowels of the earth, and that idea
Yeah,
that sounds similar
well,
to what you're talking about? Okay, yeah.
somewhat. I know that there are people out there that have made that their own specialty or hypothesis or paper, and I only applaud that. Whether they're right or wrong, that doesn't matter right here. I do believe that lava, magma creation is probably very much connected to Leonard-like, rather like, the MOXIE fusion, the oxygen fusion I pointed out. Mainstream acknowledges that water comes down, touches the mantle, if you will. That's the Moho layer, the Mohorovich layer, if I say it right, Vladimir. It's a Russian name, I think. And that's that molten thin layer. And that's where, lots of volcanic magma comes from. Why is that layer molten? Why is water involved? Because it's clearly involved. They can see that in the chemical compositions of the stuff coming up. I think there are Leonard-like fusion reactions taking place there, creating that magma. Increase the electric telluric current a little bit, meaning our solar activity. You would, put your cooker instead of on position 2, you would put it on position 4. You get a bit more heating there. Off goes the volcano. And if you put it on 10, when the sun does a really, really, really nasty cosmic burp or something cataclysmic, then the Earth, like a dynamo, if you will, or something like that, will start showing all kinds of short circuitry here and there, and whole rows of volcanoes would go off, and you would have extinction level events. This is my belief, sir.
Okay,
So,
that's
yeah.
very interesting. Now, one thing in your theory and your talk is you have talked a lot about the electricity as being the primary force, but you don't talk about magnetism. I know that there's a disagreement in the dissident community. There are some people who are proponents of magnetism being fundamental, and there are some people who say electricity is fundamental. Where do you come down on that viewpoint? And we only got like 7 minutes here.
Okay. Magnetism is very elusive for me also, for starters. Very elusive. I break my mind when I think about a permanent magnet, for starters. Now, I'm convinced it's not moving electrons or anything like that. That's not it. A permanent magnet might be the exposed positive spots in alignment, what I talked about, because iron and metals, heavier metals, no matter what you do in chemical connectivity, it is never 100% occupied in positive spots. That is why there are gaps in your metal alloy where the electrons can take place, your half-conducting story there. So they might, proposition if you will, have something to do with a permanent magnet effect. So perhaps magnetism is related to what I call those half positive charges or / Coulomb area. Perhaps that is simply magnetism, what we call two protons facing each other. Perhaps that is simply the magnetic effect. I'm throwing it out because I started out with, I do not understand magnetism enough to make a good statement here, but so this is why I see it. Electrostatic is a little bit more simplistic for me because it's, positive, negative, or at least we say positive, negative. But it's the only conclusion, of course, truly here is an electron is attracted to a proton / vice versa. That is with a amount of force, and then we translate it to forces and coulombs and charges and whatnot. But
Okay.
magnetism, yeah, difficult.
What about superconductivity? What do you have any thoughts about the Bardeen-Cooper pair theory and that sort of thing?
I'm not familiar with the detail. I do understand the topic, but not familiar with the details. Interesting point I would like to point out is that superconductivity usually happens with the really cold, meaning the very rigid. The very rigid meaning like when you have those 5, 6 spheres hanging on a little thread, and then you take off one and you let it go, and it goes like tick tock. The other one on the other side flies off and comes back, and on the right flies off, and it's free in the center. They stay still, right? That be superconductivity in my mind when you're talking an actual substance over which you try to bring across a current, right? Superconductivity of that current. So in my mind, I equate it to that tick-tock game with the 5 spheres when on the right it goes off, on the left it goes off. That big superconductivity. So as rigid as possible without any potential, movement in between. Stuff can move or absorb the shock, if you will. So all the force, because I do see all forms of energy as movement. Energy, in my mind, is equivalent to movement. Unrestricted movement, light. The rest is, the more common things that we call.
All right. We're coming up here to the end.
Sure.
Does anybody have any questions before we
One more question, very simple one. Plutonium, what is the mechanism of plutonium creation? Please tell your opinion about it. Because plutonium you can create during atomic bomb or some very high density nuclears and all this stuff. But they found plutonium in Mother Nature and they don't have any mechanism how to create it.
How much time left?
we got maybe 6 minutes, 3 minutes.
3 minutes, check. Plutonium, uranium, etc., lead are relatively quite abundant. I believe the creation mechanism of those heavy, between brackets, unstable elements is creation by processes such as fusing oxygen to an existing base metal. Barium is relatively heavy already. Add a couple of times an oxygen to it, fuse it to it, you would reach a gold or a lead or a uranium, for example. If you look at these steps and you put, for example, every time an an oxygen to it, and you start, for example, with a silicon, you end up pretty much at a uranium and a lead in between. What I'm saying is the abundance of the elements is a telltale story for the fusion of oxygen and carbons to an existing base metal. So I have a house, I add another room, I add another room, I add another room, I add another room, I have plutonium. Mind you, this is the simplistic explanation. Nature has many pathways and mechanisms. So you can add a deuterium, you can add a beryllium, you can add a boron. There has to be, maybe there has to be a beta decay step in between to reach that specific thing. So you get a palladium instead of a technetium or something akin, right? Or a palladium instead of a silver next door. So the
And
heavy
you
stuff
think
is
that this
created in.
processes, you think these processes could occur in the earth and not
Yes,
necessarily?
I think that's where they take place in the mine shafts. There's a progression of elements and certain associated with certain layers where the gold or the lead or the plutonium is. And all these things can never really be explained by standard geology. This is why geology is so important. You can't explain water with lots of gold in it deposited in that kind of amounts in quartz veins. It's idiotic.
And we
For
think in the
any
electric
process, you needed
universe,
some energy, where it came from. For any process on Mother Earth, it
Most,
must be
we
energy
have
source. What
we
is
have
the energy source?
not
we have
much.
telluric currents that run
Yeah,
underground, and we also have lightning bolts, the kind that we have never seen in our lifetimes, that create a lot of the heavy metals and gold from electric charge, from moving current, massive currents that transmute elements.
that could very much be the trigger indeed. But to answer Vladimir's question, if you add a deuteron to uranium, it yields energy still. So it's, automatically, if you will, right? Downhill
All
to the
right, we're going
bolts,
to
the
end
lower
here.
zones.
We're going to end
Okay.
here soon. I
Thank
want
you
to
so
thank
much,
you.
everybody, for this opportunity. I wanted to say that. Thank you.
I'm sure you'll be invited back to talk again. Thank you, everybody. Thank you, Edo. And we should be ending here in probably 30 seconds. So we got 30 seconds.
I would
What's
like
the
to
rate?
I would like to say that there are two diamond mines that were discovered in Australia. One was found, the other one was found by the tales of the Aboriginal, saying